Okay. Example 3. I kind of worded it a little bit differently to make it sound more awesome than what's in the book. Maybe it's not that much more awesome, but anyways. We've got our friend here, Josephine, who lives at this house here. She's traveling to her friend's house, which is 1 kilometer away. And then from the store, her friend's house is 3 kilometers away, continued along the same path that she was heading in initially. So we got a little story here, and what we're being asked to do is to create a distance versus time graph, to model what's happening. Okay? So when they say distance versus time, when I'm drawing my graph, distance versus time, what goes where? Does distance go on the x-axis or the y-axis?
Y.
I'm asking you.
What?
Distance versus time. Does distance go on the y-axis or the x-axis?
Isn't it Y?
The y-axis, good. Okay, usually they state the y-axis first, and then versus, whatever they say after that, usually goes on the x-axis. Okay, so we're going to have distance here, time here, and you will need to do this on your papers as well. Please use a graph when you're drawing your axes. Okay, we're going to make that bottom corner there 0. And we'll add our labeling in a bit, but let's just read the story first. Okay? So, here we go. Josephine leaves her home and walks to the store. Good job, Josephine. After buying a drink at a nearby store, that is, not us, is 1 kilometer from her house, she slowly jogs to her friend's house. This house is 3 kilometers from the store in the same direction she was going before. Josephine visits her friend for a while, then quickly runs back home because The Bachelor is on in like 5 minutes. You tell me, do I have to put any numbers on the y-axis?
No. Yeah.
Yeah, because I know some specific distances, right? I know that the house is a kilometer away from the store is 3 kilometers away from the friend's house. So let's just put 5 ticks on there, each indicating 1 kilometer, 2, 3, 4, 5. So this is 1, 2, 3, 4, and 5. Alright, good. What about the time axis? Do I need to put any ticks on there? Should I?
Yeah.
I mean, usually I should, but is there any indication how long she took to get to the store, or how long she stayed at the store, or how long it took her to get to her friend's house? We don't know. Okay, so we can't put any kind of scaling on the time axis. We just leave it open-ended. So let's look at the first scenario. Josephine leaves her house and walks to the store. How do I show that on the graph?
Which part?
Josephine leaves her house and walks to the store. It starts going up. Okay, so do I go like that?
No. Just
She's walking.
She's walking.
So
It's gotta be slight.
So a very gradual incline. How high do I go?
To 1 kilometer.
To 1, because the store is 1 kilometer away. Okay? So a gradual increase until I get to 1 kilometer. That's her walking to the store.
She's so slow.
Okay?
You don't know though. It might be like in seconds time.
After buying a drink at a nearby store that is 1 kilometer from her home, she slowly jogs to her friend's house.
So you have to show that she stopped.
We have to show that she stopped. How do we show that she stopped at the store?
Straight line.
Flat line, just for a bit, right?
It's like she's dead.
She says like, hey there, Sam, how's it going?
Sam.
How's your kids? Okay, so she stayed at the store for a little while, didn't go anywhere. Now she jogs to her friend's house. How do I indicate that?
It's gonna be steeper than the run.
It's going to be steeper than the walk. Where do I stop?
4.
4, right? Because now she's 4 away from her home. So steeper than the walk, and I stop at 4. Okay? Says the house is 3 kilometers from the store. We already got that. In the same direction she was going before. Already got that. Josephine visits her friend for a while, then quickly runs back home because The Bachelor's on in like 5 minutes. So she stays with her friend for a while and then bolts back home. How do I show that?
Flatline first.
Flatline first. Why?
Because she's not
No
doing anything.
movement.
Because they're talking about boys and The Bachelor and how awesome math class is, right? And then she bolts back home. How do I show that?
Straight down.
Down.
Kind of.
Could I do straight down?
No.
No.
What would that mean?
Time.
Super
Time
travel.
travel.
She time traveled basically, right? Could I do this? Would that make sense?
No, because then you're going back in time.
Because then you're going back in time. You can't do that. So probably something like this, right? She ran back home. So we need a steeper line than walking, definitely. We don't know if she was, maybe she was steeper than the run. And I guess it's a little steeper than the run. But does that make sense?
Yep.